This is lesson 7.5. In this lesson, we will learn how to solve exponential equations, and in part 2, we'll learn how to solve logarithmic equations. First of all, for any function in the form f of x or y equals b to the x, if b to the u is equal to b to the v, then u equals b. So here's an example. We have 4 to the x plus 2 equals 4 to the 3x. Since both base numbers are the same, we have 4 here and here, just like this. Since the bases are the same, we can make the exponents equal to each other. So x plus 2 equals 3x. And we can solve this linear equation by subtracting x on each side. So 3x minus 1x is 2x. Divide by 2 on each side, and we get x equals 1. If we plug back the 1 back in to the original function, we should see that it works. 4 to the 1 plus 2 is equal to 4 to the 3 times 1. 1 plus 2 is 3, and 3 times 1 is 3, so 1 is the correct answer. These are some examples that relate to this rule we just learned. The problem is the bases are not matching here. So what we're going to do is change the two bases, the 16 and the 8, so they have a matching base. So 16 we know is 4 squared, but 4 to the what power equals 8? That we don't know. So how about 2? 2 to the 4th power is 16. 2 to the 3rd power is 8. So if we change this 16 into a base 2, 2 to the 4th power, and multiply that by the 3x that was already there, then we can, on the right side, make this be 2 to the 3rd power, because 8 is 2 to the 3rd power. Now, since we have matching bases, we can say 4 times 3x is equal to 3. So 4 times 3 is 12. 12x equals 3. Dividing by 4 on each side, we get 3/12. And so x equals 1/4. And if you put that back into the original equation, we get 16 to the 3 times 1/4 equals 8. So 16 to the 3/4 is 8. So 4th root of 16 cubed must be 8. 4th root of 16 is 2. 2 to the 3rd is 8. And yes, it does work. Okay, in our second example, we're going to want to change the 27 and the 81 to have a matching base. And in this case, that base will be 3. 3 to the 3rd power is 27. Multiply that by the exponent that was already there. And 3 to the 4th power is 81. Since we have matching bases here, we can just look at the exponents. 3 times 3x equals 4. 9x equals 4. Dividing by 9, we get x equals 4/9. And you can check that answer, but it will work. These examples, though, we're not going to be able to make them have matching bases. There is no base that 15 and 285 share. So we're going to have a plan B. And plan B is this. We have to do the opposite of an exponent. And the opposite of an exponent is a log. So if we put log base 15 here, the base 15 on the log will cancel with the base 15 that has the 3x on it, and that just leaves us with 3x. Anything you do on the left side, you must do on the right side, so we put in a log base 15 on the right. And so this right side we have to calculate using the change of base formula. So that's log 285 divided by log 15. That equals 2.087. Make sure you carry it out to 3 decimal places. And then we can divide each side by 3, and we get x equals 0.696 to 3 decimal places. If you plug 0.696 back into our original equation here for x, 15 to the 3 times 0.696 should equal 285. And you can check that. Okay, next example. Solving for x here, we want to get rid of the 5. So if we do a log base 5, that will cancel the base 5 that has the exponent, and we get 2x. On the right side, we put in a log base 5, and we calculate using the change of base formula. Log of 130 divided by log of 5. That equals 3.024. Then we will divide both sides by 2, and we get x equals 1.512. That's as far as we're going to go in this first half of this lesson. There is more, like solving using a graph or a table. We will do these in class, and story problems, we're going to do some of these in class. So that's it for this first half.